Hello everybody, and welcome to the beginning of page 24 in the workbook. And in this example, we're going to kind of draw on a graphical observation that we made at the end of the previous example, example number 2. We discovered that we did the trapezoid rule and the midpoint rule to estimate the same integral, and discovered that one was an overestimate and one was an underestimate. Okay, and it turns out that there's a graphical way to predict when we're going to get an over or an underestimate. Okay, and that's what we want to talk about here. Right, turns out that that has to do with the concavity of the graph. Okay, so we want to look at two situations, f being either concave up or concave down, see if we can predict in those situations when we're going to get an over or an underestimate with these two ways of estimating an integral. Okay, so I want you to look at the first two pictures down at the bottom here and notice that we've got two copies of a function that has the typical concave up shape. Okay, and what I'd like to do is to draw in one trapezoid and one midpoint rectangle and just see what happens here. Okay, so suppose we want to estimate the area under the curve using just one trapezoid. Okay, well, if we drew the trapezoid, it would look like this. And notice that we get a lot more area than we want. If we shaded in the area of that trapezoid, we would be adding a lot of extra area to that curve. So the trapezoid rule is too big, which means that Tn, the estimate using trapezoids, would actually be bigger than the integral in the case where our function is concave up. Okay, now let's contrast that behavior with the midpoint rule. What if we wanted to estimate the integral using a midpoint rectangle instead of a trapezoid? Well, there, what we would do is to find the middle point, find the point on our function, and then draw in a rectangle that has that as its height. Okay, does that give us too much or too little area? Okay, you can kind of see that the area that we miss over here on the left is a lot smaller. Or I'm sorry, I said that backwards. Back up a second here. Okay, sorry about that. I'm just going to redraw this again. Okay, there's our rectangle. Okay, and so notice that on the left, we're getting some extra area, but it's a really small amount of area. We are missing a whole bunch of area over here on the right. And so the fact that we're missing a lot more area than we're picking up tells us that this midpoint rectangle is an underestimate overall. We're missing area that we should be adding. And so the midpoint rule gives us a number that's too small. Okay, so for a concave up function, the midpoint rule is an underestimate and the trapezoid rule is an overestimate. Okay, what about if it's the other way around? Okay, so these two functions over to the right are concave down. Let's draw in a trapezoid there. And notice that the shape of the curve forces the trapezoid to be below the curve. And so the trapezoid rule is actually going to be too small in this case, meaning that our estimate using trapezoid should be less than or equal to the integral. Okay, what about for the midpoint rule? Okay, well, if we find the midpoint and go up to our curve and draw in our rectangle, notice that this time we get too much area. Okay, we're getting a bunch of extra area over to the left, and that's bigger than the area that we're missing over to the right. And so the midpoint rule for a concave down function is going to be too big in general. Okay. And finally, I just want to say a brief word about error. Okay, we are approximating integrals when we use the trapezoid and the midpoint rule. And so there's generally going to be a difference between the integral and the estimation. And we just have a name that we give it. We're going to call it E sub t and n. What that stands for is error in the trapezoid rule with n subdivisions, if you want to put words to all of that. Okay, and then similarly, if you want to measure the error between the integral and the midpoint rule, we'll call that E of mn. Okay, the error in using the midpoint rule with n rectangles.